Master in Anatomy and Physiology with Indra Mani Pandey.
Welcome back, guys. This is my another lecture about connective tissue. Last time we talked about loose connective tissue. Now we're gonna focus on dense connective tissue in today's lecture. Dense connective tissue is a part of connective tissue proper, and what we're gonna do today is we're gonna talk briefly about dense connective tissue. We're gonna focus on three parts. Dense connective tissue is divided into three parts. Those are dense regular connective tissue, dense irregular connective tissue, and elastic uh, tissue. So we're going to talk about those. Let's dive into today's topic. Okay, so let's go forward. Okay, let's see here. The first slide going to focus on the dense regular connective tissue. The first thing what I want to do is just focus on the diagram and try to figure out what's going on there and what are the elements in the diagram. Okay, so can you label the figure? From past experience, you should just know that there are some structures going on there and you can figure out what might those be, right? So let's see this. As you go, like, as you see here, I pointed out the arrow. This looks like something, some kind of cell, right? And this looks like a fiber, and they are running parallelly, right? Usually they looks like parallel in shape. So what I want to say, this structure, these small passages, is called fibroblast. As you know, the function of fibroblast help in formation of the fiber. And what kind of fiber is this? As you know, this is a collagen fiber. This is a collagen fiber. Okay, so these are fibroblasts and this is collagen fiber. And another thing you need to understand is they are running, these fibers are running parallelly. Okay, they are running like parallelly. There is no like zigzag pattern here. They looks like, they are running parallel in this particular case. Okay, basically the dense regular connective tissue comprises structures like, as you know, ligaments, right? Ligaments is a part of dense regular connective tissue. Another is called tendon. Okay, tendons. And another thing is called aponeurosis. And we're going to focus aponeurosis during our skeletal system in more detail. Okay, and as I told you, there are some ground substances and there are some cells like fibroblasts there, and we cannot see more than that, right? Usually it's like so dense, so we cannot see other structure here. The main function of ligament is to connect bone to bone. It connects one bone to other bone. Okay. So, and what about the tendon? The tendon, what it does is it connects muscle to bone. Okay, muscle to bone. And what about aponeurosis? What is aponeurosis? You might, guys, you might thinking about like what I'm talking about right now, right? So aponeurosis is a flat sheet of or ribbon of tendon, like basically a material that anchors a muscle or connects it with the part of the muscle it moves. Okay, so that's what is aponeurosis is. You can see on the long bones usually aponeurosis. Okay, and as I mentioned you, the structure is basically is a parallel structure. You're going to see here these are regular fibers. They run parallel to each other in the same direction, right? Like this way, parallel structure. If you see that kind of structure, then you must think about this dense regular connective tissue. The main function of the dense regular connective tissue is to support and strengthen the tissue, but only if stress from one direction. So if the stress is coming from this direction, it can hold that stress. If the stress is coming from other direction, it cannot, because due to its like its structure, how it's like arranged, right, in a parallel direction, it can only get that stress only from one direction, not from all other direction. And as I mentioned you, the location is in the ligaments, tendons, and the aponeurosis. And that's what we need to know. And this slide I got from Mariv, Anatomy and Physiology. Then you can go and just check this out on more detail if you want, okay? And now let's move on to dense irregular connective tissue in next slide. Okay, so this is super good. Look here, dense irregular. What it signifies is irregular, means these fibers are not running in one direction. They are in multi-direction. One is going this way, another going that way, and this way. So what you can think about here is, so this is an irregular one. Okay, if you see something like this, that is irregular. And these small patches that we just mentioned in the regular connective tissue, right? So what are these? These are the fibroblasts. And what are these fibers? These fibers are, again, these fibers are collagen fibers. The only one difference is they are running in all direction. These are not parallel. And these are more widely distributed throughout the body. And as I mentioned you, they are highly condensed nuclei, and they do not have enough cytoplasm. They have minimal amount of cytoplasm on them. Okay, and what they do is basically they provide strength and support for areas like subjected to like stress from multiple direction. It can hold stress from multiple direction because fibers are running in different directions. So you can have stress from any direction, and your body can maintain those. Okay, that's what it is. And the main location to find these things, I want to say, are submucosa. If you look the submucosa in intestinal tract, intestinal tract, you can find this one. You can find in dermis of the skin, right? You can find fibrous capsule or fascicle, which is a like periosteum or perichondrium, right? So what you can find is called fibrous capsule. You can find in a fibrous capsules, right? And you can find in a fascicle. Okay, so these are the location where you can find dense irregular connective tissue. Okay, so what I want you to know here is when you see this diagram, you have to figure out this is irregular because these are running in all direction. The small patches are fibroblasts, and these are found in submucosa, in intestinal tract, and dermis. You don't need to know like all locations, but remember that where you have like a higher stress from different direction, that's the place where you're going to find irregular connective tissue, that dense irregular connective tissue. Okay, now last but not least, we can talk about elastic connective tissue. The elastic connective tissue, when you look this, what do you think about that? Okay, look, these are like some kind of small snails or like earthworms going on right there, right? So this is a general idea what we're looking at. So it is elastic because we can actually stretch it, right? So we try to stretch it, so that's why it is elastic basically. When you see something like this, you must know that it is an elastic fiber, and it differs from other because you cannot see, you cannot see those fibroblasts actually there, right? So what you're seeing here is the elastic fibers running kind of like zigzag pattern but following their parallel direction. So fibroblasts occupy only few spaces between fibers, but we cannot see usually here, but we can think about that. And the main function is like basically it allows tissue to recoil after like stretching. If you're trying to stretch something, you have to recoil again to go to that back position, right? So if you stretch this, right, if you're trying to stretch, so it has to go back to its same position. Okay, that's how physiology works, right? So that's what it is. Okay, and another thing what I want to mention here is it basically you can find this one in like large arteries, like when the heart pumps blood, it goes to aorta, right? The aorta is one of the large artery where you can find this elastic connective tissue. And you can find this one in walls of bronchial tube within certain ligaments in vertebral column, and you can find this in suspensory ligament or penis. You can find this one in trachea and even in vocal cords. Okay, so again, this I got from Mariv, Anatomy and Physiology book. This was very helpful diagram because it illustrates a lot, and these fibers are elastic fibers. Okay, because we're talking about elastic tissue in particular case, right? So that's what it is. Now, I'm going to ask you some questions and give some answer and some thoughts about that. Okay, for example, if you have tendons and ligaments are made of tissue that has high tensile strength, right? We know that tendons and ligaments have high tensile strength. Then what type of tissue makes up tendons and ligaments? Remember that we talk about that, right? Dense regular connective tissue. If something comes along like ligaments and tendons, remember it's a dense regular connective tissue. And another thing what I want to mention here is, for example, if you cut your index finger, basically, then you're gonna damage your connective tissue. What kind of connective tissue that might be? Okay, you have an index finger, right? So if you cut that index finger, what kind of connective tissue, like you are prone to damage? The idea is here is you have to think about that. What are the structures present on the index finger? We can think about like tendons, right? So if you think about tendons, the answer must be dense regular connective tissue, right? So that's the take home message. Another thing what I want to mention is I got this concept from Marev Anatomy and Physiology book. For example, what happens, okay, if your movable joints are made up of elastic fibers? What might happen? Okay, if your shoulders joints are made up of elastic fibers, okay, so you have a shoulder joints, right, which allows some flexibility in, and you have a knee joints, it allows other type of flexibility, but it does not. Sometimes you have an exception, you cannot move joints in other direction, right? What happens if you have elastic connective tissue there, okay, elastic fibers there? The answer is, what's going to happen is the joints going to be floppy joints, because elastic connective tissue, basically what it allows is it allows the freely movable type of environment, right? We don't want our joints to move everywhere, right? So that's not in our control, so we cannot do that. So joints would be more flexible, okay. In some cases it might be helpful, but other cases it might not be. For example, if you have a vertebral column, let's say, and you don't want to bend in opposite direction, otherwise you're going to mess it up with the vertebral column, right? So that's what it is, right? What another thing might happen is you can have misalignment and you can dislocate your shoulders or the other part of the joints. So that's the thing we don't need and we don't like that. So the nature already built that system for us, and that system is perfect, so we don't want to mess up that one, okay? So those are the three things I want to mention you guys, okay? Just think about that, okay? Think deeply what's going on and what I'm talking about, and you can review this lecture again and again and get that concept, and take care. I'll see you in the next lecture. Bye-bye.
Please subscribe to see more videos regarding anatomy and physiology.